Hey guys, Mr. Gran here, 6.1 naming polynomials as well as adding and subtracting polynomials. So all about polynomials in chapter 6. So we're starting with the basics. We can rewrite in standard form, we'll learn what that is. We can identify what the leading coefficient and the degree are, so we'll learn about those. And naming, describing them by their degree and their number of terms, so we'll learn about that. And then some actual math, adding and subtracting the polynomials. So adding or subtracting two equations from one another. All right, so some vocab to start with. What do some of these words mean? A polynomial is this. It's a mathematical expression using numbers and letters. Really, it's this. It's an equation that looks like this, where it's a variable with an exponent. And there might be a number of them, there might only be one, but there's not things like square roots, there's not things like sine or cosine or anything like that. It's only exponents, and the variable is also not the exponent. All right, what the degree of the polynomial is the highest exponent. Now this is in what's called standard form because the highest exponent is first, then the next highest, then the next, and then the lowest exponent where there's no exponent down there. So the highest degree, or the highest exponent, that is the degree. So this has a degree of 3. The number of terms are these chunks that are separated by pluses and minuses. So in this case, there's 4 terms. And the leading coefficient is the number that's all the way in the front when it's in standard form, and it's the one that goes with, it's the coefficient or the number that's being multiplied to the variable of highest degree. Okay, so when it comes to degree, there is one little exception here, and it's when we get into multivariable things. So as a quick example of that, these three, how do we find the degree when there's more than one variable? In the previous one, the only variable was x, so the degree was a little easier to find. If it's more than one degree, think about how you would multiply, what happens when you multiply exponents, when you learned about that in Algebra 1. If I said this was x to the 4th times x to the 6th, it would make x to the 10th. Well, we do kind of the same thing when we're talking about degree. We still add the exponents of the two variables, but only to find the degree, not to actually simplify this or anything like that. So for that first one, with the 4th and the 6th, we have a degree of 10. With our second one here, we've got an exponent of 7, an exponent of 9. There's no exponent here, so let's remember that that means the exponent is really 1. And so if we do 7 plus 9 plus 1, we get a degree of 17. Now we've got a little bit trickier one on the bottom here because we've got more than one term. This first term has a degree of 11, 5 plus 6. I don't add that to the other terms, right? This term has a degree, this term has a degree. These are separate terms, so you have to approach them separately. This one is 3 and 7 makes a degree of 10. Then that tricky little x without an exponent gets a 1. Plus 8 is 9 for the degree of that last term. So the term with the highest degree is the first one here, 11. And so this polynomial has a degree of 11. All right, so let's get into naming now. When we name a polynomial, they all have two names. The first name describes the degree. The second name describes the number of terms. So our different vocab terms that go along with this. This is a really vocab-heavy lesson. If it's a first degree, it is linear, right? Y equals mx plus b. That's x to the first power. That's a line. It's a linear equation. Second degree, quadratic. That's our good old friend, the whatever you call that thing, parabola. Those are quadratic equations if it's x squared. Third degree, a cubic, right? Raising to the third power cubes something. Fourth degree is quartic, or you can just say fourth degree. Fifth degree is quintic, or you can just say fifth degree. So two ways to do it there. And anything higher than fifth degree, we're just going to say sixth degree, seventh degree, eighth degree, and so on and so forth. All right, then the number of terms. If there's only one term, right? Mono means one, so that's a monomial. Bi means 2, so binomial. Tri means 3, so trinomial. We don't get into quadnomials and pennomials and stuff like that. If it's 4 or more terms, we just call it a polynomial. All right, so first examples, classifying polynomials. We're going to identify the leading coefficient. We're going to rewrite it in standard form, identify the leading coefficient, degree, number of terms, and then name it. So a lot of stuff in each one. And to save some time writing, I'm just going to use an animation here. So with this one, rearranging this, the minus 2x squared is going to go first because that's the highest exponent, then the x, then the 3. Once I have it into standard form like this, the leading coefficient is that first number, which is -2. The degree is the highest exponent, which is 2, and then there are 1, 2, 3 terms, so the number of terms is 3. It is a quadratic because it's x squared for the highest exponent, and because there are 3 terms, it is a trinomial, so quadratic trinomial. All right, our next one, a little simpler. There's only 2 terms. We're just going to move the -8 in front and the 3 to the back so that it is the x to the 4th first and the x squared second. Leading coefficient then is the -8 that's out in front. The degree is 4 because of the exponent. Number of terms, there's 2 of them, so 2 terms. So this is a quartic binomial or a 4th degree binomial. Our next one. No rearranging to do here, right? This is already in standard form. Leading coefficient is 6, degree is 3. There's 1 term, no pluses or minuses, so 1 term. It is 3rd degree, so it's cubic, and 1 term means it's a monomial. Then our last one here, highest exponent is 4, so that's going to move, that term moves in front. Next one is squared, so that's going to be second. The x is going to be the 3rd term, and then the 3 is going to be the last term, and it will look like this. Then the leading coefficient is the -5. The degree is 4. There are 1, 2, 3, 4 terms, so this is a quartic or 4th degree polynomial. All right, so adding or subtracting polynomials. When we are adding and subtracting polynomials, we're only combining like terms. This means that the exponents don't change. It's not like when you multiply x squared times x cubed to get x to the 5th, right? If you're adding them, the exponents stay the same. And when we're subtracting, we want to be sure to distribute the subtraction sign so we don't end up like accidentally adding when we're supposed to subtract or vice versa. Okay, so a couple of these. If you think back to Algebra 1, you maybe did things like putting boxes around certain terms, circles, triangles, that sort of thing. On my note key, I think I have them in different colors, but we'll do that. So maybe we box the cubes. Maybe we circle the squares. I guess that kind of makes sense. Maybe put a triangle around just the x's. And now we can combine our like terms, and we can just sort of match them up. So I've got a 2 and a single x cubed, which makes 3x cubed. So that kind of takes care of these two. I only have this one term of x squared, so 5x squared. That takes care of that. Then my x's, I've got a minus x and a plus 7x, which makes a plus 6x. And then your plain numbers, 9 and 4 makes 13. All right, now the only difference here, when we're subtracting, we're going to distribute that minus in, and that's going to make this plus a negative x squared. I'm going to do the minuses in red. This becomes a minus 6, and this becomes a plus x. So it changes all of the signs. Then I can kind of use the same strategy. Maybe we circle these guys. Maybe the ones, there's an x over here. We'll put a box around that. Maybe we'll just leave the plain numbers alone, and now we'll just combine all our like terms. So -2 and -1 for the x squareds makes a -3x squared. That takes care of those. Then we've just got a plain x, so plus x, that takes care of that. And then a 3 and a minus 6 makes a minus 3. Like that. All right, what does the next one look like? All right, so some are difference here. So now we've just got a few more. This would be a good point to pause, try it on your own, and then see how it's done by the master. Okay, so we're subtracting, so let's distribute that minus in and change our signs. So we'll change this to a plus, this to a plus, this to a minus, and this to a minus. Right, so I hope that shows up okay on the video that this plus is changing to a red minus and that plus is changing to a red minus. All right, so we've got some c squareds. We'll circle them. We've got some c's. We'll maybe box them. And then I'm just going to leave the plain numbers alone. 8c squared plus 3c squared is 11c squared. Negative 4 minus 1 for the c's is negative minus 5c. And then 1 minus 5 is minus 4, like that. All right, couple more. Quick addition one. Pause it, try it, resume when you want to see it. We've got some m squareds. We've got some m's. And we've got some plain numbers. 3 plus 4 for the m squareds makes 7m squared. 2 minus 3 for the m's makes a minus m. And 1 plus 1 continues to be 2. If you're ever interested in something really weird, look up lunar math, where 1 plus 1 equals 11. You won't regret it, or maybe you'll instantly regret it. All right, so distribute because we're subtracting. That means this will be a minus 4. This will be a plus 3y, and this will be a plus y squared. All right, we've got a y squared here, a y squared here. We've got a y here and a y here. Negative 4 plus 1 for the y squareds is negative 3y squared. 1 plus 3 for the y's makes 4y. And 5 minus 4 makes 1. All right, I think that is the last one. All right, so if we've got any questions, again, email your teachers, let us know, and we'll try to do the best we can to kind of support you and make sure you can succeed in our classes.